So this is the third question that we are taking. So it is also related to equivalent resistance, but here the question is asked in a different way. Here we have to calculate the total circuit current I. We have a 50 volt DC voltage source which is connected across this resistor combination, okay, resistance combination, and we have to find out the total circuit current I. Now, in order to calculate the total circuit current I, we have to calculate the total equivalent resistance of this combination. Okay, the I will be 50 by R equivalent. Okay, the total circuit current. So for that we have to calculate the equivalent resistance. So for now, just forget about the 50 volt voltage source. We have to calculate the equivalent resistance across these 2 points. Let's say they are X and Y. Just forget about the 50 volt voltage source for now. Okay, now just by looking at this circuit, you can see that these two resistors, 4 ohm and 4 ohm, they are in series. They are in series. The 4 ohm and 4 ohm resistors are in series. So what we can do is that we can combine them into one, and the total equivalent resistance of the combination will be the sum of the two resistances. So it will be 4 ohm plus 4 ohm, 8 ohm. We have simply added them. So this is the equivalent resistance of these two resistors. Next, these 2 ohm and 2 ohm resistors are in parallel. This end of the resistor 2 ohm and this end is connected at one common point, and this end of the same 2 ohm resistor and this end is connected at another common point. So they are in parallel. So the parallel equivalent of this will be 2 into 2 by 2 plus 2, which will be 4 by 4, which will be 1 ohm. So we can replace this resistor combination with a 1 ohm resistance. Okay, here also we are moving from right to left. Okay, in this direction we are moving in this direction. So we can replace this resistor combination, the 2 ohm and 2 ohm, with a 1 ohm resistance. Now look at the 1 ohm and 8 ohm resistors. The 8 ohm resistor has its one end connected at this point, and also the 1 ohm resistor has the same end connected to this common point. Let's say the top ends of both the 1 ohm and 8 ohm are connected at one common point. The bottom ends of the 8 ohm and the 1 ohm resistors are also connected at this point. It means the voltage across them will be the same. The voltage across them will be the same, and current division will take place at this point. So the 1 ohm and 8 ohm are in parallel connection. So we have to calculate the equivalent resistance of the combination. So let's calculate that. It will be 1 into 8 by 1 plus 8, it will be 8 by 9. Okay, so let us just convert it into decimal form. 8 divided by 9, 0.889. Okay, so that is the equivalent resistance. So let us just convert it into 1. .89 ohm. Now the 10 ohm and 0.89 ohm are in series connection. Okay, they are in series connection. So the total equivalent resistance of this entire resistor combination, okay, this entire resistor combination is 10.89 ohm. Okay, this entire combination has resistance of equivalent resistance of 10.89 ohm. So if we connect the plus minus 50 volt here, the current flowing I will be V by R ampere, which will be 50 by 10.89 or 10.89, sorry, be 4.59 ampere. This current value will be 4.59 ampere. Okay, so here the question was asked in a different way. We had to calculate the total circuit current. So in order to do that, we have to determine the total equivalent resistance of this entire circuit. So here also we use the same approach. We approach the circuit from right to left. Okay, we approach the circuit from right to left, and we kept on calculating the equivalent resistance of the various resistors, the combination of resistors which we encountered, and finally we simplified the circuit into one resistance, which is the equivalent resistance of the total circuit, which we calculated as 10.89 ohm. Okay, now for calculation of current, we simply found out the ratio between the voltage and the resistance. So we calculated the current as 4.59 ampere. So let us see another question.